Hello guys, no. So ngayon class, tapos na tayo sa mga konsepto regarding sa discussion natin sa parallel forces. Ngayon, proceed na tayo sa ating mga sample problem and let's start with our sample problem or situation 13. So sabi dito, the loading on the bookshelf is distributed as shown. So ito yung distribution, no. So pag tinignan mo daw, parang magiging ano siya, uniformly distributed load hanggang dito na 2 pounds per foot. And here, mas mabibigat yung libro. So, magiging uniformly distributed load na 3.5 pounds per foot. So, given ang mga distance between supports, 2.75. So, dito, ilan? Hindi binigay, no? Pero ang binigay, yung end ng first distributed load, 4 feet. Ito, hindi, yung length ng another distributed load is 1.5 feet. So, determine the magnitude of the equivalent resultant force, yung FR, yung lahat ng distributed loading, and also, determine its location measured from O. So, ano daw yung distance ng FR from O. So, again, madali lang ito class, no? So, meron lang tayong ditong dalawang distributed load. So, ito, highlight ko ng dilaw, yung isa, and ito naman yung isa. So, highlight natin ang kulay blue. Okay, so with that, I think we can now draw. So, kung rectangular yan, and then yung length niyan is 4, so 2 meters from A, or 2 feet from A, which is midspan. Okay, hindi pala midspan, no? Midpoint nung rectangular distributed load. So, at that location, nandiyan yung tawagin muna nating F1. Okay, and then again, sa midpoint nung another distributed load, so dito sa 1.5, sabihin 0.75 from the end nung load na yon, nandoon naman yung F2. So, therefore, yung FR niyan is somewhere between F1 and F2, siguro. So, let's assume na lang na yung FR is what? Let's say, nandito na lang siya, no? Ito yung magiging FR. Okay, so we know to solve for the resultant, that is just equal sa summation ng mga forces. So, dito, consider natin class yung positive direction as the direction ng resultant. So, there are cases kasi dito na magiging magkaiba yung direction ng mga ng mga forces natin. So, mayroong mga downward, tapos may combination ng upward, pero parallel pa rin naman sila. So, okay lang naman yon. Pero kapag ganito, na same yung direction, so assume na lang natin na kung ano yung direction na yan, na provided sa figure, yan na lang yung positive natin, no? So, therefore, in this specific scenario, consider natin downward forces positive. Okay lang. So, wala namang mawawala doon. So, downward forces as positive, so magiging yung FR is equal sa F1 plus F2. So, now, we'll solve individually for F1 and F2. So, F1 is just the area ng load diagram. So, that is base times the height, wherein base is 2.75 feet. And then, yung height is 2 pounds per foot. So, sabi ko nga magka-cancel yan. So, matitira unit ng force. So, that is how much class? So, that is 5.5 pounds. So, how about for F2? So, the same. Area ng rectangle, base times the height. 1.5 feet times the height na 3.5 pounds per foot. So, cancel lang feet. Matitira unit ng force. Ilan yan, class? That is what? 5 okay. So, wait lang. So, dito pala, hindi siya 2.75, no? So, ingat-ingat lang tayo. Ang 2.75, distance lang yun between supports. So, ang kailangan natin yung total length nung uniformly distributed load, which is 4. So, lagyan natin dito 4. So, hindi pala ito ang sagot class. Okay, so, wag tayo maging careless. So, 4 times 2, that is 8 pounds. So, ito, 5.25 pounds. Okay, so muntik na tayo magkamali. So to solve for FR, that is just the summation, 8 pounds plus 5.25 pounds. Okay, so and FR now equals 13.25 pounds. Okay, which is what? Letter A, so we are correct. Okay, so yun lang. Be careful lang, no? So next, determine its location measured from O. So, class kasi, etong drawing natin na to is just an approximate location ng FR. It can be located kasi dito eh. Pwede siyang dito located, no? Bago mag-O. Or, yun nga, lagpas na siya ng O. So, hindi natin sure yung exact location niya. So, ang gagawin kasi natin dito, gagamit tayo ng Varignon's theorem. Okay, Varignon's theorem ang gagamitin natin. So, pag ginamit mo kasing reference point yung O, baka magkamali tayo kasi nga hindi natin sure kung siya ba ay nasa right nung O or nasa left nung O. So, mahirap gamiting reference point yung O. So, ang practice dito, yung madaling point na gamitin as reference point is yung first point, no, yung point A. So, ito yung ating magiging reference point. So, dyan tayo magmo-moment ng mga forces natin. Okay, so define lang natin yung mga distances. So, line of action na itong F1. So, papunta sa A. So, ito yung distance niya, yung perpendicular distance, no? So, ito. So, sabi nga natin, exactly midway siya or dun sa midpoint nung length nung uniformly distributed load, which is 4 feet yon. So, therefore, ito is magiging 2 feet. Okay? How about naman itong F2? So, line of action is ito. So, measured from A, ito naman yung perpendicular distance na yon, di ba? So, how we determine that? So, itong distance na to is 4. Tapos, yung matitira dito, kalahati ng 1.5, so 0.75. So, therefore, ang distance niya is 4.75. Okay? Now, yung FR, line of action, is vertical. So, from A, so ito naman yung distance niya, no? Perpendicular distance niya. And then, tawagin muna natin to class for the meantime as XR. Okay? So, yun na yung mga distances from our reference point A. So, we can now use Varignon's theorem. So, sa Varignon's theorem, gamit tayo ng red siguro. Ito na lang. So, magiging what? FR times XR equals what? So, summation ng moments ng components. So, first component F1, moment arm is 2. And then plus F2, the moment arm is 4.75. So, just simply plug in the values. So, we have here FR, nasolve na to, 13.25 pounds. And then, times XR. So, equals F1, that is 8 pounds. And then, times 2 feet. Plus 5.25 pounds. And then, times 4.75 feet. Okay, so with that, we can cancel the unit ng pounds. So, remaining unit is naka-feet. So, therefore, yung XR, yung value niyan is in feet. Okay, so solving for XR, that is how much? So, sagot is 3.0896 or in 2 decimal places, that is 3.09. So, wag magpadalos-dalos dahil ang 3.09 ay nasa choices at hindi yan yung sagot. Dahil ang XR na yan is the distance nung resultant force measured from A. Okay? Measured from A. Eh, ang tinatanong, from O. No? From O. Ngayon, ano pala yung ano natin dito? Conclusion natin. So, kung ang distance niya ay 3.09, so ano siya? Is it on the right side of point O or on the left side? So, 3.09 to. While yung distance na to, A to O is how much? 2.75 lang. So therefore, ito yung distance na hinahanap. And correct na nasa right nga siya. No? So ito yung distance na hinahanap natin. So to solve for that, that is just simply 3.09 minus itong 2.75. Okay? So, therefore, ayun o. So, 3.09 minus 2.75. Yan yung distance na hinahanap natin. And that is how much? So, that is 0.34. 0.34, the unit is feet. And the correct answer is yung letter A. Okay? So, gets ba yun, class? Gets yun? So, kung gets yun, proceed na tayo ngayon sa next sample problem natin. So, wait lang. Okay, so situation 14 tayo. The beam is subjected to distributed loading as shown. So, combination siya ng triangular distributed load and trapezoidal distributed load. So, question is, determine the magnitude of the equivalent resultant force of the equivalent resultant force of the distributed loading, and also determine its location measured from B. So, in distance again nung resultant from B naman. So, in this case, divide lang natin yung loading natin into basic shapes. So, una, itong triangle. So, again, yung resultant niyan is nasa 1/3 from the height. So, tawagin natin itong F1. So, in this case, trapezoidal yung ka-partner niya. So, dahil mahirap nga yun, so, convert ulit natin ito into basic shapes. Small triangle, saka yung rectangle. So, tawagin natin yung sa small triangle as F2. And then, dito sa rectangle as F3. So, yung combined tawag dito, combined forces nila or yung resultant nila. So, saan natin lalagay yon? So, let's say, lagay na lang natin siya sa right nung B. Okay, mapuprove naman natin yan later on kung nasa right ba talaga siya ng point B or nasa left. So, ito yung ating FR. So, therefore, to solve for FR, that is just the summation ng lahat ng forces. So, since all forces is downward, so safe to say, gamitin na lang natin downward forces positive. So, that is F1 plus F2 plus F3. So, solve muna natin individually F1, F2, F3. F1 is triangle, so that is 1/2. Base is 12. So, di ko nalagay yung unit ha, kasi naka-feet naman ito. Tapos, yung intensity natin naka pounds per foot. So, magka-cancel ang foot or yung feet, matitira pounds. Okay? So, yung height is 800. So, ilan yan, class? That is 4,800 pounds. How about for yung F2? Yung small triangle. So, zoom in tayo, class, para hindi tayo magkamali. Kasi alam naman natin yan, 1/2 base times height yan, di ba? 1/2 yung base naman for that is 9 feet. Baka magkamali tayo sa height. Okay? So, take note, yung total height is 800. No? Ito yung 800. And then, dito, sa rectangle, ang height niya is sinabi itong 500. So, therefore, ang matitira para dun sa small triangle is what? 800 minus 500, yung 300 lang. So, ayun, baka lang maging careless tayo dun. So, 300 lang yung height niyan. Okay? So, ilan yan? Okay, so that is what? 1,350 pounds. And lastly, yung F3, yung rectangular load. So, that's base times height. Base is 9. Height is 500. So, this one is 4,500 pounds. So, ayan, to solve for FR, summation lang yan. 4,8 plus 1,350 plus 4,5. Ilan na yan, class? So, sagot, 10,650 pounds, no? In kilopounds, so divide mo lang ng 1,000, so that is equal sa 10.65 kilo pounds or kips. Okay, so next is determine its location from B. So, dahil hindi nga natin sure kung dito ba yung correct location ng FR, so mahirap gamitin reference point yung point B. Kasi kung nasa left pala siya, maling moment yung magagawa kasi natin, no? So, ang gawin natin, use natin itong point A as our reference point. Okay, para sure tayo na ang moments lang ng forces natin lahat is clockwise. So dito pala hindi na natin pinakita, no, yung pagko-consider ng direction kasi sa previous discussion natin, 'di ba? Sabi natin magko-consider tayo ng mga positive moment. And yung positive moment is depende doon sa magiging moment ng resultant. So, kung ang resultant is pa-clockwise, so yun yung gagamitin nating positive. Kung ang resultant is mag-counterclockwise, so use naman natin to simplify yung solution natin. Clockwise moment naman yung positive. So, depende sa moment ng resultant. Pero in this case, no, yung resultant naman is what? Anong ikot niyan sa reference point? Clockwise yan, no? So, ang consideration dito is clockwise moments, positive. So, yung F1 clockwise, positive. F2 clockwise, positive. So, lahat sila positive dito. Okay? So, dito ganun din. Yung moment ng resultant force is clockwise. So, therefore, consider natin clockwise moments, positive. Okay, so ito yung consideration natin. So, F1 clockwise, F2 clockwise, F3 clockwise, walang problema. Lahat sila is additive, no? So, now, kunin muna natin yung mga distances, no, perpendicular distances nila from our reference point. So, yung F1, ito yung line of action niya. So, from A, ito yung distance na kailangan natin, which is what? 2/3 yan nung base. So, yung base dyan is 12. So, 2/3 ito ng 12. Okay? For F2 naman, ito yung line of action niya. So, from A, ang distance niya is ito. So, paano kunin yan? Di 12 muna plus yung 1/3 naman ng base, which is yung 9. So, 12 plus 1/3 of 9. Okay, so sana nakikita niyo pa yung sinusulat ko. And lastly, yung F3. So, ito yung line of action niya. So, from A, ito naman yung perpendicular distance niya. So, that is how much? Yung naunang 12 plus kalahati nung 9, 9/2. And then, denote natin yung perpendicular distance na itong FR. So, as, XR. Okay, perpendicular distance, XR. So, kung isusulat natin yan, magiging what yan? Total force times its perpendicular distance, XR. So, moment ng resultant equals sa summation ng moment ng component. So, first component is F1. Yung distance niya is 2/3 ng 12. And then plus yung F2. Ang distance niya is 12 plus 1/3 of 9. And then plus F3. Ang moment arm niya is 12 plus 9/2. Okay, so just simply plug in na lang natin. Hindi ko na siya sulat ulit. So, ito lalagay mo dito is yung 10,650. Ito lagay mo dito for 8. Ito 1,350. And then this one 4,500. So, ang unknown na lang dyan, class, yung XR. So, ilan yung XR na yan, class? Okay, so ang sagot in 2 decimal places is how much? 12.48. And then yung mga units ng distances is naka-fit. So, this one is naka-fit. So, 12.48. Again, nasa choices yan. At wag magmadali dahil hindi yan yung sagot. Ang tinatanong, yung distance from B, measured from point B. So ngayon, verify natin no, kung tama ba yung drawing natin na siya is on the right nung B. So, di ba, ang distance from A to B, no, from A papunta dito sa B, ayan, is 12, no, base sa figure. Eh, siya is 12.48. O, di tama nga, nasa right siya. 12.48 feet, di ba? So, tama nga, nasa right siya ng B. So, to solve its distance from B, edit 12.48 minus 12. O, hindi ko nasusulat yan, class, dahil ang tamang sagot ay A. 0.48. So, this one is our correct answer. Okay, so gets. So, next problem tayo, class. So, kunin ko lang. Okay, so, ayan, situation 15 tayo. So, the beam is subjected to the distributed loading. The resultant force and couple moment acting about the fixed support are required to be 0. So, nagets nyo ba yun? May binigyan na siyang clue, no? Sabi, yung resultant force daw, dapat is what? 0. So, ganun din daw yung couple moment. So, yung magiging moment ng mga forces natin sa fixed support, no? Yung moment niya is dapat 0 rin. So, yun yung magiging mga clue natin sa mga solution natin later on. So, makikita mo dito, class, meron tayong uniformly distributed load. So, may dimension na B, and then may intensity na 40 pounds per foot. And we also have an upward triangular loading na 60 pounds per foot. And then may horizontal distance na 6 feet and then 10 feet from the fixed support. So, first question, determine the length of the uniform distributed load and determine the position A. So, ilang kinukuha? A and B. So, again, start lang tayo from the basics. So, yung rectangular load natin is acting downward. Ayusin natin. So, ito siya, no? So, tawagin natin yan as F1. And itong triangular load natin is upward. So, dito naman siya. Upward. So, ito yung isang example na tinutukoy ko kanina na yun nga, yung parallel forces natin is not necessarily na same ng direction na kung downward lahat. So, dito nakita ka ng isang downward, isang upward, pero pares naman silang vertical. So, parallel pa rin sila. Okay? So, may binigay class di ba? Anong sinabi? Di ba, to solve for FR, that is just the summation ng mga forces natin. But in this case, since we have opposite directed forces, so we consider na ng direction. So we can consider na lang yung conventional na upward to be positive, no? Kasi may magkaibang direction eh. Ngayon may sinabi, yung resultant dapat 0. So therefore, i-equate lang natin yun sa 0. Okay? So, FR equals what? So, yung F1 is downward, so negative F1. And then, yung F2 is upward, so plus F2. And then, dapat daw sila ay magsi-0. So, solve natin yung F1. So, that is area nung rectangle, base times the height. Yung base is unknown, yung height is 40. So, therefore, 40B. And then, for F2, area ng triangle, 1/2. Base is 6, height is 60. So we have here how much? I have here 180. So hindi ko nalalagay ang units, pero that is 180 pounds. So using this one, negative F1 plus F2 equals 0. So masolve na natin yung B, di ba? Negative 40B plus 180 equals 0. So, B now equals, that is 4.5. Okay? 4.5. And then, the unit ng mga distances is naka-feet. So, therefore, this one is our answer. And that is letter A, so correct. Okay, so next, para makuha natin tong position A, no, yung distance A, kakailangan natin yung yung second na binigay niyang given. Sabi, yung magiging moment daw, no, ng mga forces natin at the fixed support, so ibig sabihin, yun yung magiging reference point natin, no, yung fixed support, dapat still 0. So, considering itong fixed support as our reference point, so dyan tayo magmo-moment, di ba? So, define lang muna natin yung mga moment arm. So, itong F1, ito yung line of action niya. Ayan. So, measured from our reference point perpendicularly. So, this one is what? A plus kalahati nung B, di ba? A plus B over 2. So, how about for F2? So, in distance niya, perpendicular distance, no, from its line of action. So, that is how much? Yung naunang 10, di ba? Ayun, no, naunang 10. And then plus, yung 1/3 nung base na 6. So, 10 plus 1/3 of 6. So, ano lang yung gagawin natin, class? We take lang yung summation ng moment, no, summation ng moment sa fixed support. So, tawagin natin to, class, as point A. So, we take the summation ng moment at A na lang. And then, sinabi, yung pinagsama-samang moment dapat daw magsi-0. So, in this case, use na lang din natin yung conventional direction for positive moment. So, let's consider clockwise moments positive. Okay? So, clockwise, ang magka-clockwise moment dyan is F1. So, that is F1 times the moment arm na A plus B over 2, where yung B is 4.5. Okay? And then yung F2, so ang ikot niya, pag ganyan, that is counterclockwise. So, magiging minus F2. And then yung moment arm is yung 10 plus 1/3 of 6. So, sabi yung combined moments nila is dapat magsi-0. So, we have the value na ng ng F2, di ba? Yung F2 is 180. And itong F1, so makukuha naman natin yan dito, edi 40 times 4.5. Ano lang din yan, class, 180. So, ito magiging 180. So, for this specific equation, the only unknown is letter A, and we can solve for that, and that is how much, class? Okay, so ang sagot is 9.75, and then the unit ng distances is naka-feet. So, this one now is our answer, and that is letter D. So, correct. Okay, so ayan So, madali-dali lang naman siya. So, now let's proceed sa next sample problem natin. So, kunin ko lang. So, I think pwede na yan. Okay, so situation 16 tayo, class. So, the beam is loaded as shown. So, in this case, class, ang distributed load natin is hindi na common, no? So, yung imbis na basic shapes lang siya, ang nangyari, defined na yung curve, no? Or yung value ng intensity natin as a function of x, wherein ito yung x-axis niya, ito yung w-axis. So, parang lumalabas, ito yung 0, 0, no? Parang ito yung 0, 0 coordinate. So, now, how to solve for this one? Kung ano na siya? Tag dito, varying na, no? Uniformly or varying na yung load natin, and then express as a function of x. So, the same lang naman ang konsepto. Ganun pa rin, class. Yung FR is still the area nung load diagram. Area pa rin. And then yung location niya, kung tatanungin man, no, which is tinanong nga, determine the magnitude. and determine the location. So yung location niya is still nandoon pa rin sa centroid nung ating load diagram. So para magawa natin yun class, a-apply na lang naman tayo dito ng same concept pa rin class. So paano ba kumuha ng FR? Yung total resultant force, 'di ba sabi natin, that is just the summation ng lahat ng components, 'di ba? So very simple. So dito, ang components na gagawin natin is gagamit tayo ng mga strips, no? Differential force, no? Na magre-represent ng component. So let's zoom in this one. So let's try to use a strip located somewhere here, no? So strip, kasi sabi natin, mahirap kunin yung area kung ganyan yung curve. So simplify natin, let's assume or let's get na lang muna a rectangular strip para madali kunin yung area. Okay? So yung rectangular strip na yan, meron siyang dimensions na yung vertical represented ng intensity W, and then yung horizontal is a differential x dx, no? Very small amount x. So kung meron tayong W may dx, kapag kinuha natin yung area niyan class, ano makukuha natin? Okay? Pag kinuha natin yung area niyan, hindi makukuha natin yung niya, yung force para sa kanya, which is yung force na yon is yun yung tinatawag nating differential force. So ayusin ko lang. So sana makita. Ayan, no? Yung force na makikreate nung area, nung differential area na yan is a differential force. At yung differential force na yan represents one component nung total force natin. So anong gusto kong sabihin? Kasi maraming strip yan, di ba? Tabi-tabi yan, yung mga strip na yan. So kanya-kanya yon, meron silang equivalent differential force. So pag pinag-plus natin lahat ng strip na yon, so parang nakuha na rin natin yung resultant, no? Yung total force. So ganun lang, no? So same concept lang. So sabi natin, di ba? Ang differential force using the figure ay yung area nung rectangular strip natin, which is paano yung area class? Length times width, di ba? Length times width. Ayusin muna natin. Where yung length is yun yung yung intensity. Take note, to class yung intensity para yan, omega yung symbol. So nagmukha lang siyang W. Kaya akala mo baka ito yun. Pero yung length natin, which is yung vertical side, yun yung intensity, and then yung width natin, no, yung horizontal, is yung dx. So para siyang W dx. Okay? So ibig sabihin, yung amount niyan represents yung differential force. So sabi nga natin, pagpapag-plus-plusin natin, di ba? So kung calculus ang pinag-uusapan, plus, that is equivalent sa integration. No? I-integrate natin, pagkasama-samahin natin. So we integrate differential force, pagsama-samahin lahat ng differential force. So integrate na lang din ito. So sabi natin, pag pinagsama-sama natin yan, yung mga differential force na yon, makukuha natin yung total amount ng force F. So, and copy lang ito. So W dx. So ibig sabihin, para makuha natin yung total force, we will just integrate W dx. Okay? So, ganun lang pala siya class, no? Medyo madali lang. So, wherein yung W, in terms ng x, so that is what? 2.5 of x cubed. And then, this one is dx. So, saan natin papatakbuhin yung mga strip? So, di ba yung strip magsisimula sa may A, dito. And then, matatapos yung strip dito sa sa may dulo. No? So, ibig sabihin, parang tatakbo siya. Kung ito ang ating x-axis, no? So, magsimula tayo from x is equal to 0 hanggang x is equal to 4. So, ang limits natin is from 0 to 4, and then that one represents na yung ating resultant force. So, tawagin ko tong FR. Okay, so now FR, ilan yan class? Ay, may sagot na, no? So, the answer is 160 newtons. Okay, so from the choices, that is letter D, so correct tayo. Okay, so sana nagets nyo yung application ng ano natin, calculus, no? So, napakahalaga class ng calculus kasi marami talagang problems na talagang may application siya, no? And at the same time, huwag kayong class matatakot kapag gumagamit tayo ng calculus kasi may calculator ka naman, 'di ba? Na siya na yung magso-solve no nung ano mo, yung provided equation mo. Given that marunong ka lang mag-interpret and then mag-create ng equation, relationship. So ikaw yun na lang yung magiging part mo, and then si calculator na later on yung magso-solve para sa iyo. So wag ka matakot basta alam mo kung paano gumamit ng calculus, okay? So next we have yung location. So let's say nasaan kaya located diyan? So tawagin na lang natin dito located yung So dito located yung resultant FR. So paano makuha class yung location? So ang gagawin lang natin, varig nonce. Okay? So hahanap lang tayo ng specific point na pag momentan natin. So ang specific point na yan is itong point A. So ito ang ating reference point. So diyan tayo magmo-moment. So kunin muna natin yung mga perpendicular distances nila. So yung FR, ito yung line of action niya. So from A, ito yung niya, perpendicular distance niya, no? So tawagin natin tong XR. So ngayon, sino yung component na papaikutin natin? Di yung mga differential force natin. So in this case, ito yung differential force. At ang moment arm niyan, so kung ito yung line of action niya, ito yung moment arm niya. Which is what? Denoted yan by X distance. So parang total force times distance na XR ay equal sa pinagsama-samang moment ng mga component, which is yung isang component is differential force, yung perpendicular distance niya is X. Okay? So, ganun pa rin class. Ano pa rin naman yun? Pasok pa rin yun sa Varignon's theorem natin. Okay? Susulat natin. By Varignon's. Okay, so angat natin. Ayan, Varignon's theorem. So, moment ng total force, FR times XR ay equal sa pinagsama-samang moment ng mga component. Wherein dito nga, yung component is yung differential force and then yung moment arm niya is X. Tapos sabi natin, pinagsama-sama, summation. So, that is equal again as the integral. Okay? So, very basic. Wag natin sabihin very basic class. So, asan ba equal itong integral ng df? Ito yan, di ba? So, parang i-transform lang natin siya ng ganito. W dx and then may times x sa labas. So, yung x, pasok na lang natin dito. So, magiging wx dx. Okay? So, ito bring down lang. Bring down. So, ngayon, simplify natin W in terms of X. So, kita pa ba? Kita pa? This one is parang 2.5 X cube. Tapos may X pa. And then dx. So, on the left-hand side, so we have here FR. Yung FR may value na tayo niyan, di ba? 160. Yung XR na lang yung wala. Okay? So, saan natin siya i-integrate? So, the same from 0 to 4. So, therefore, itong right-hand side, magkakaroon siya ng value at equal yan sa class. Equal sa 512. So, in this case, parang siyang 160 times XR is equal sa 512. O, ayun, solvable yung location niya from A. So, that is how much? 3.2. And then, unit is meters. So, that's it, no? So, that is now our answer. 3.2, and from the choices, that is letter A, so correct. Okay ba yun, mga sirs, mga ma'am? So, madali lang basta alam mo kung paano i-apply ang calculus sa mga problems natin. Okay? So, ngayon class, actually, pwede naman natin itong isolve, no? Itong problem na to. ng isa pang solution. Ito, pinresent ko lang ito kasi may mga cases talaga na papahirapan ka ng examiner, no? Gagamitin sine waves, no? So, no choice. Kailangan talaga mag-calculus. Pero class, for this specific problem, meron tayong choice dito eh. Sinasabi kasi dito that yung equation no, nung curve natin is naka-x cube. Ibig sabihin, this one is a third degree na curve. Okay? Ngayon, pag-usapan natin yung pagkuha ng mga area, centroid na mga first degree, second degree, third degree, and so on, n degree na curve. So, may pattern kasi yun. So, yun yung pag-usapan natin. So, pag sinabi mong first degree, yun yung line. Okay? First degree. So, para siyang triangular load. So, pag sinabi natin second degree, yun yung parabolic. Ito, second degree. So, ganito naman siya. And for the third degree, so, ganun pa rin naman yun. Naka-curve na. So, almost the same lang siya ng second degree, yung itsura. And so on, no? So, this one is our third degree. And lagay tayo dito, nth degree. So, ayan. Naka-curve lang. So, may pattern kasi to. So, let's say ito yung height. Ito yung base. So, ganun din dito, no? Base, 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 and height. Height, height. So, para kumuha ng area, no? That is just simply, alam mo yung sa triangle, di ba? This one is how much? 1/2 base times the height. E di ilan tong sa sa second degree. Ano to class? Sabi nga natin parabolic, di ba? Spandrel. So, this one is 1/3 base times height. So, mararamdaman mo ng class yung total pattern nun. So, for a third degree, ito is 1/4 base times the height. So, for an nth degree na curve, so ito is 1 over n plus 1. So, ayusin na natin to h2 and 1 over n plus 1 times base times the height, no? So, if n is 1, so 1 plus 1, 1/2. So, first degree. Parang ganun. So, we can apply that. Now, sabi nga kasi natin, area corresponds dun sa FR, di ba? So, apply nga natin kung pwede. So, area ng third degree, ilan yon? 1/4. Base is 4. Height is 160. So, magka-cancel lang 4. O, tama nga, class. 160 Newton. So, walang kahirap-hirap. Ang bilis lang palang masolve ng ating resultant. Pero sabi ko nga, take note, hindi naman class kasi always may pattern. Pag pinahirapan ka na iba yung function, kakaiba yung function. So, gagamitin mo talaga yung itong calculus. Which is, kaya mo yan class, kaya mo yan. So, next, paano kumuha ng location ng centroid? Kasi 'di ba sasabi natin yung FR ayan is located yan doon sa CG, sa centroid. So, para makuha natin yung centroid, so balik tayo dito sa natin, pattern natin. So, let's say ito yung centroid. Ang magiging measurement natin is always papunta doon sa vertical side. So, ito papunta rin doon sa vertical side. Ganon din to. Papunta sa vertical side, and this one, distance from the vertical side. Okay? Yun yung gagamitin natin ng formula. So, tawagin natin yan as x distance. Tawagin lang. So, para makuha class ang x distance, that is simply what? So, simulan mo dun sa triangular. So, pag triangular, di ba ano yan? Ang distance na yan is 1/3 nung base. Di ba? Tama ba? So, para naman sa second degree spandrel, so ito is magiging 1/4 naman ng base. So, class, makikita mo na yung pattern nun. So, for this one, 1/5 ng base. So, ito, magiging ilan to class? 1 over n plus 2 ng base naman. Okay? So, halimbawa, first degree. So, 1 plus 2, 3. No, 1/3 ng base. So, ganun siya. So, for this specific problem, third degree, so 1/5. Now, 1/5 pala siya. So, yung distance na to, papunta doon sa vertical side, 1/5 of 4. So, ang tinatanong yung papunta dito. Tama ba? Balikan nga natin, hindi ko binasa eh. Determine its location from A. So, tama. So, kung 1/5 yun doon, ito magiging 4/5, di ba? Of 4. O, ilan yung class? 4/5 of 4. So, that one is equal sa 3.2 meters. Okay, so, ayun. So, it's either you solve it by pattern or yung conventional na calculus. So, kung nagka-calculus ka, mas okay. Pero kung alam mo rin to, okay rin naman. Makuha natin yung same exact answer. Okay, so ayun. Sana gets class. And then we're now down sa ating last problem for this particular topic. So kunin ko lang. So ito actually, pwede nang ikaw na lang magsagot nito eh. Pero sige. Sagutan na rin natin class. Sayang naman. Ayan, situation 17. The beam is loaded as shown in the figure. So we have three forces F1. Ito na lang F1 natin. F2, F3. Determine the magnitude. Determine its location from O. So napaka ano lang neto class, no? Simple. Sa lahat ng sinagutan natin class, ito na yung pinaka-simple. So ito yung F1, F2, F3. So I think symmetrical naman yan class. No, makikita mo symmetrical, oh. 500 to 500 at 250. Tapos, yung distance is 3 by 3. Sure na ako dyan, class, no? Kung praktisado ka, na yung resultant niyan is dito tatama sa location ng F2. FR. Pero anyways, wag tayo magpakasigurado. Solve na lang natin siya manually. So, FR, summation ng mga F. So, in this case, lahat sila downward. So, hindi na natin kailangan mag-present ng direction. So, this one magiging F1 plus F2 plus F3. So, magiging 500 plus 250 plus 500, edi 1 to 50 pounds or in kilopounds, divide by 1,000, 1.25 kilopounds. Okay, so that is what? Letter D, correct. Napakabilis lang. Next is mag-moment na lang tayo, Barrigan's theorem. So, ang reference point natin is itong O. So, gawin pa ba natin yun? Rekta na natin, oh. Yung distance ng FR papuntang O, tawagin nating XR. So, magiging FR, XR equals yung F1, 500, and then, ayusin nga natin. So, F1 times distance is 3, plus F2, ang distance niya is 6, plus F3, ang distance neto is 9. And then, saka natin palitan isa-isa. So, this one is 1, 250, 500, 250, and then 500. So, yung XR equals ngayon saan? Okay, so sagot is 6. Okay, 6 feet. So, nasa choices, correct. And which is tama nga dun sa assumption natin dahil symmetrical siya. Ito yung distance niya, class, oh. 6. Okay, so ayun guys, no? So tapos na tayo sa natin, discussion natin regarding sa mga parallel forces. So sana na-gets niyo siya. So next topic natin is yung mga non-concurrent forces naman natin. Saka yung parallel forces natin in 3D. So madali lang din naman yon. Gamitin lang natin yung konsepto na naaral natin sa topic na to. So ayun guys, so thank you guys for watching. So kung wala nang question, so see you next time. God bless.